Hi, and welcome to the short presentation of our paper Human Interpretation of Saliency-based Explanation over Text. My name is Hendrik Schuff, and this is joint work together with Alon, Jacovi, Heike, Adel, Yoav, Goldberg, and Thang. Consider the following setup. We have an input which is passed to a model, and then this model returns a prediction. And a typical question in explainability is which parts of the model input did influence its prediction. And a typical answer to this question are these heat map style explanations. And what we want to find out in this paper is how these heat map visualizations are perceived by human explainees. And more concretely, we want to find out if the explanation as it is communicated seemingly objectively by the explainer is the same as the explanation which is understood by the human user, and we hypothesize that these are not the same and that there are various factors which bias this perception process. And to find out whether these biasing factors exist, we first run a crowdsourced user study in which we show participants explanations and ask them for importance ratings for words within these explanations, and then we analyze the collected data with GAM models. And what we find via these GAM models is that there are many factors which have significant impact on the human ratings, for example, word length, sentence length, and word sentiment. And we argue that none of these effects should have an effect on the human's ratings, because the explanation alone should communicate all the information. And besides this quantitative indication that there are these biasing factors, we also find additional qualitative support via user comments that there are these biasing effects which influence user perception. And in addition to this first study, we also run further generalization studies in which we test whether these results also hold for another language, another AI task, and also another attribution score. And in the third part of the paper, we want to find out if we can, via visualization alternatives, mitigate these biases, and therefore we propose two visualization alternatives. The first one are bar charts, and the second one is a saliency correction method, in which we use the GAM model that we did fit before to iteratively correct the saliency predictions such that they are perceived in a better way. And what we find in the last user study of our paper is that the bar charts help to mitigate the biasing effect of word length, and similarly the saliency correction method mitigates learning effects that we observed before during the course of the experiment. And to sum up, we wanted to answer whether the explanation as it is communicated by an explainer is perceived in a biased way by a human explainee, and if yes, which factors influence this biased perception. And therefore we first ran a crowdsourced user study and analyzed the results using GAMs, and there we found that various effects have a biasing impact on user ratings. And in the second part of the paper, we show that these effects can also be found for a different language, a different AI task, and different attribution score. And in the third part of the paper, we explore if we can mitigate this bias with visualization alternatives, and we show that the two methods we did propose can mitigate some of the biases. And to sum up, the takeaway message of this paper is that to build effective explanations, we need to understand users and their perception, and we cannot develop explainability methods without taking into account the users. And with that, I'm at the end of our presentation, and I'd like to thank you a lot for your attention.